If you were in North America about 13,000 years ago, things were starting to look up. The world was emerging from the last great ice age, and finally it was getting warmer again. At least that's how it seemed, because without warning, the Earth's climate kinda glitched. Within what might have been as short as a single human lifetime, a huge swath of the Earth fell back into an ice age. Temperatures in some places dropped by as much as 10 degrees, and they stayed that way for over 1,000 years. Scientists call this period of intense chill the Younger Dryas. And to understand why it happened, we have to talk about a lake bigger than anything around today, and what happened when it broke free. At the end of the last ice age, much of the world was covered in vast glaciers. Here in North America, an ice sheet up to 3 kilometers thick, called the Laurentide Ice Sheet, stretched all the way from the Arctic down to New York. As temperatures warmed up, the ice began to melt. Some of the meltwater flowed out in rivers and streams, but a lot stayed trapped behind the ice, collecting in vast lakes. In the west, one of the biggest was Lake Missoula, whose waterline is still visible in Montana today, and in the east was Lake Agassiz. And when we say big, we mean big, like took up half of Canada big. Its exact size likely changed a lot over its lifetime, but at one point Agassiz might have been the size of the Black Sea, and covered parts of North Dakota and Minnesota, as well as Manitoba, Ontario, and Saskatchewan. All of that water was likely being held back by ice dams, giant lobes of ice, kind of like the wall from Game of Thrones, but even bigger and much, much thicker. And as the Earth warmed up, these dams started to weaken, until one day they stopped working. Maybe the walls collapsed, or maybe the water found a way to creep out underneath. But either way, this monster lake started to drain, sending what may have been over 9,000 cubic kilometers of water hurtling to the ocean. One study estimated that if it took an entire year for the lake to drain, the flood would have moved an average of 300,000 cubic meters of water every second, which would make the flow more powerful than the Amazon River. At first, scientists thought the water might have gone through the St. Lawrence River Valley, rushing over what would be modern Montreal. But in the last few years, scientists have started looking at Canada's Mackenzie River Valley, where the terrain resembles the ancient spillways in Washington's channeled scablands. All that floodwater would have swirled around the Arctic Ocean until it made its way to the Atlantic Ocean, breaking the Earth's weather. You see, there's an interesting and kind of important set of salty ocean currents in the North Atlantic, called the Atlantic Meridional Overturning Circulation, or AMOC. They work like a big conveyor belt in the ocean. In the tropics, water from the depths rises to the surface and is warmed up. And this warm water moves northward in currents like the Gulf Stream. As it makes its way to the frigid north, the water loses some of its heat, keeping a lot of places on the way nice and warm. Eventually, it cools down so much that some of it ends up frozen in ice, leaving behind cold, saltier water, which is denser. That water sinks to the seafloor and heads south again, and the whole cycle repeats. But when all that fresh water hit the AMOC, it diluted the water in the North Atlantic, causing the AMOC to slow down and maybe even stop. And when the current stopped, the heat stopped, like everywhere. Scientists think this might have been what triggered the massive cooling we saw during the Younger Dryas. Without that warmth, huge swaths of the northern hemisphere essentially went back into an ice age. Forests and grasslands that had been expanding in the warmer climate died back as the land turned into tundra, which might have dealt a blow to ice age giants like mammoths, who were already starting to disappear. And don't forget, this was only about 13,000 years ago, which means there were people around too, and there's evidence that they were also negatively impacted by the sudden freeze. In North America, the onset of the Younger Dryas is associated with the disappearance of the Clovis culture, known for its distinctive stone points, which was one of the first cultures to become widespread on the continent. Of course, there are other possible explanations for what caused the Younger Dryas, like a comet or asteroid impact or a volcanic eruption, but neither is considered as well supported as the megaflood hypothesis. And not every megaflood caused global havoc. In fact, megafloods were happening all across the northern hemisphere. The Altai floods of Central Asia, for instance, may have caused a domino effect of floods stretching from Siberia to the Mediterranean Sea. And in the Pacific Northwest, the Missoula floods carved a swath of strange landforms, now known as the channeled scablands in eastern Washington state. In fact, it was the research done by geologist J. Harlan Bretz into the Missoula floods that eventually set the stage for the study into Lake Agassiz.
That's right, Stefan. I'm Blake de Pastino, co-host of PBS Eons. And when J. Harlan Bretz found what he thought was evidence of a massive flood in the Pacific Northwest, other scientists weren't exactly receptive. At the time, everyone thought that geologic processes were gradual and slow, and big floods just didn't fit into that view of the world. But Bretz was sure that he was seeing the remnants of epic ancient floods, and eventually he and a colleague were able to prove it. If you want to learn more about how this scientific mystery unfolded, and how geologists uncovered evidence of massive floods that changed the world, we've got a whole episode on that over at PBS Eons.
Thanks, Blake. Researchers now think Lake Agassiz actually grew and either burst or spilled at least twice more over its roughly 4,000-year lifespan. And much smaller versions of this phenomenon still occur today. In Iceland, they're called Jökulhlaups, and they still have the power to reshape the landscape. But none of these floods managed to cause the same kind of global climate changes as the one 13,000 years ago did, though many had smaller effects. Lake Agassiz is a reminder that while Earth might seem rock solid, many of its systems are complicated and sometimes fragile. And knowing what's happened to our climate before could shed light on what's happening to it now. Today, people are once again watching out for fresh water in the Atlantic. The AMOC is still around, and while there isn't a single giant lake pouring into it all at once, scientists are becoming increasingly worried that the collective runoff from melting ice will cause a similar slowdown. And that means studying the megafloods of the past could be critical to understanding the future global effects of climate change. Thanks for watching this episode of SciShow, and thanks to Blake for helping us explain how these megafloods happened. If you liked learning about how events in the past shaped the world we see today, you'll probably like a lot of the videos from PBS Eons, and you can check them all out over at youtube.com/eons.